Today we are going to start with unit vector. What do you mean by unit vector? A vector having magnitude 1 and some specific direction is called unit vector, and it is unitless. Suppose there is a given vector A. There is a vector A and having a direction north. Then we will call a vector A as unit vector in the direction of north if magnitude of vector A is 1. If a magnitude of vector is 1 in some specific direction, we will call that vector as a unit vector of that direction. This is a concept of unit vector. How to find the unit vector from the given vector? Just read it. Any vector divided by its magnitude gives the unit vector in the same direction. Let's take an example. There is a vector A whose magnitude is 5. That's in some direction indicated by n cap. And it is asked, what is a unit vector? What is unit vector in direction of n cap? Then how to find a unit vector in the direction of n cap? What we will do? We will find the magnitude of given vector. What is the magnitude of given vector? 5. Then how to find a unit vector? The vector it divided by magnitude of itself. It will give you the unit vector in that direction. One is a magnitude and this is a direction. Now this will be known as unit vector in the direction of m. Okay. Now we will discuss rectangular component of vector. Read what is written over here. Whenever a vector is expressed as a sum of two mutually perpendicular vectors, then we call the perpendicular vectors as a rectangular component of the vector. There are infinite ways of doing this. To resolve the vector into the more perpendicular components, imagine a rectangle whose diagonal is given vector. The side of such rectangle are the rectangular component of the vector. Now let's look what it says. Suppose there is a vector A. Suppose there is a vector A. This is x-axis. If you will see what is the component of vector A along this axis, this angle is theta, then it will be A cos theta. Similarly, if you will take the y-axis, what will be the projection or component of this vector along this? It is going to be A sin theta. This length, this magnitude is going to be A cos theta, and this magnitude is going to be the A cos theta. The same, this will be the same now as A sin theta, and this will be same as A cos theta. Now if you look, you can see a rectangle. You can see a rectangle, and these two perpendicular components forms a vector A. Forms a vector A. If these components were represented in a form of vector, then I can say now the vector, this vector shown in a black color and this vector shown in a blue color combinedly forms a vector A. That's why the A cos theta thing and this A sin theta thing will be known as rectangular component of the vector. But here it is a magnitude. Now it is a magnitude. How to convert it into the vector? How to write it in terms of vector? Multiply the magnitude with a unit vector of that direction. This is the x-axis. As we have already discussed, the unit vector in the direction of x-axis is represented by I cap. It means this is a I cap. This is a vector. This black color vector can be written as this. Similarly, how we can represent this vector? In a y-axis, we write the unit vector as a j cap. So this vector can be represented as a sin theta j cap. Now, the vector A can be written as a cos theta I cap plus a sin theta j cap. Because if you will sum these two vectors, you will find a vector A as a resultant, and we call these vectors as a rectangular component of the given vector A. A rectangular component of vector A. Okay, this is all about the rectangular component of a given vector. This I cap and j cap, we are going to discuss again in detail. Don't worry about these things. How to represent this and what do you mean by it. Okay, now we will discuss a unit vector along the coordinate axis. Unit vector along the coordinate axis. We are going to discuss the unit vector along the coordinate axis in a Cartesian coordinate system. Here we are going to discuss about x-axis and y-axis. We will introduce the z-axis later. Here we are going to discuss a unit vector along the coordinate axis, and specifically for the x-axis and y-axis. Suppose this is a x-axis and this is a y-axis. We represent a unit vector along the x-axis as I cap and unit vector along the y-axis with j cap. And for minus of x-axis, it's going to be minus of I cap. And for y-axis, it's going to be the minus of j cap. These are the unit vectors along the axes. Okay, now see how to represent a vector in a coordinate axis. How to represent a vector. Let's take one example. Suppose there is a vector in a xy plane like this. This is x-axis and this is y-axis. There is a vector drawn in a xy plane like this. This is vector A. First, what we will do, we will find its component along the x-axis. How to find a component along the x-axis? This is going to be the component of vector A along the x-axis. Suppose this angle is theta, then it's going to be A cos theta. Similarly, find its component along the y-axis. Draw the perpendicular. This is going to be the component of vector A along the y-axis. The small a I have taken. This is going to be A sin theta. A sin theta. As we know, this is a x-axis now. All the vectors in this direction is the same as direction of x now. All are having a direction of x. Similarly, for this is a one component of vector A and this is another component of vector A. It means the vector A can be written as what is the x-axis component? A cos theta multiplied by the direction of x-axis plus y-axis component A sin theta multiplied by the unit vector of y-axis. Suppose I am naming this as a ax I cap, then I am representing this with ay AY j cap. This is a standard method to represent any vector in x and y axis. You can say xy plane. This is a standard method to represent any vector in a Cartesian system. So we will call this as a Cartesian representation. Such representation is called Cartesian representation, because we are discussing a Cartesian coordinate system. Such a representation are called as Cartesian representation. Okay, take one example. Suppose a given vector is vector 5 is given as 4i cap plus 3j cap. What it means? There is a vector whose magnitude is 5 unit and its x-axis component is 4. This is ax now. X-axis component is 4. And what is the component of it in a y-axis? Its y-axis component is 3. Ay. This is 3. This is also going to be 3. This is going to be 4. Here, if you will see, the 3 is what? 3 is a ay and 4 is ax. X-axis component is ax and y-axis component is ay. Suppose this angle is theta, then how to find the theta? Then theta will be equal to 3 upon 4. It means I can write tan theta is equal to y-axis component, y, I am writing y, divided by the x-axis component, no? Tan y upon tan x. This will be the angle of resultant vector from x-axis. Angle of resultant vector from x-axis. Okay. Now take another example. Suppose the given vector is 10. Then, and it is written like minus 5 minus of 5 root 2 j cap. Okay, how to draw it? This is x-axis, this is y-axis, this is minus of x, this is y, this is minus of y. Its x-axis component is minus of 5. Its x-axis component is minus of 5. And y-axis component is 5 root 2. 5 root 2. Then it means, just complete the rectangle. This is a resultant vector. This is minus of 5. Ax is minus 5 over here. And ay is minus of 5 root 2. Minus of 5 root 2. Minus of 5 root 2. Then this is a given vector. How to find the angle of a given vector from the x-axis? Let's say angle is theta. This will be a of y divided by a of x. Now, it means minus of 5 root 2 divided by minus of 5. Tan theta is going to be root 2. Theta is going to be under root, tan inverse root 2. This is going to be the angle of the given vector from the x-axis. Okay, it's clear? The Cartesian representation of any vector. How to represent any vector in a Cartesian coordinate system. Now we will discuss how to represent a vector in a polar form. We are going to discuss how to represent a vector in a polar form. Just read what is written over here. When a vector is specified in terms of its magnitude and angle which it make from x-axis, we call it polar representation. We call it polar representation. We call it polar representation. Now look, suppose there is a vector A. There is a vector A. This is x-axis. This is y-axis. It is making angle theta from the x-axis. Making angle theta from the x-axis. What is the magnitude of A? It will be A now. And theta is the angle of A from x-axis. If the vector is represented like vector A is equal to magnitude angle theta. If the vector is written like this, we call this as a polar representation of any vector. Polar representation of any vector. Polar representation. If the polar representation of any vector is given, you can directly see the magnitude of vector and what angle it make from the x-axis. Angle from x-axis. And this is a magnitude of given vector. This type of representation is known as polar representation. As we have seen in a Cartesian coordinate system, how the vector is represented. The vector is represented by its component in x-axis multiplied by the unit vector of x-axis plus the y component of the vector multiplied by the unit vector in the direction of y. This is known as Cartesian representation and this is known as polar representation. Now we will see if the polar representation is given, how to get the Cartesian representation, and we will also see if the Cartesian representation is given, how to convert it into the polar representation. First we will see how to convert a polar form into the Cartesian form. Suppose in a numerical the vector is given in a polar form, how to get its Cartesian form. We are going to convert the given vector into the Cartesian form. Consider a vector R having a magnitude of capital R and making an angle of theta with x-axis. It means it is given. There is a vector R whose magnitude is capital R and making angle theta from the x-axis. Always remember, in some books this is also written like magnitude @ theta. This is the magnitude and this is the angle from the x-axis. This is a basic representation in the sum book, but we are going to follow this one. Okay, as it is written, suppose there is a vector, the vector R, and it is making angle from x-axis as theta. Now it is given the vector R is making angle theta from the x-axis and the magnitude of R is capital R. Now we will see its component in the x-axis. As we know, the magnitude of the given vector is R. This means this value is going to be capital R cos theta. Similarly, what will be the value of this one? This is going to be R sin theta. Now it means if I am going to write this vector in a Cartesian system, how I will write? Vector R will be equal to, what is the value of Ax over here? Ax means the component of the vector in the x-axis. This is R cos theta multiplied by the I cap. Then what is the y-axis component? R sin theta. I am going to multiply it with y-axis unit vector. This is a j. It means here we have formed, this is a Cartesian coordinate form. Cartesian coordinate form. What is the value of Ax? This is the Ax, no? This is the Ay. If you will see, what is the form of Cartesian coordinate? Any vector is represented in the form of Axi cap plus Ay j cap. Here the same form. We have converted this polar form into the Cartesian form. Let's take one example. Suppose there is a vector r whose magnitude is given as 10 and making angle of 120 degree from the x-axis, and it is asked to convert it into the Cartesian form. Okay, what is the magnitude of vector r? This is 10. What is the value of theta? Theta means angle the vector r is making from the x-axis, 120 degree. How to write it? Vector r will be Cartesian coordinate ax I cap plus ay j cap. What is the value of ax? Ax is going to be given by r cos theta. R cos theta means 10 multiplied by cos 120. Ax will be what? Minus of 5. Similarly, what will be the value of ay? R sin theta. R is 10 sine of 120 degree. This is going to be 5 root 3. Now put this value of ax and ay. The vector r will be given by, what is the value of ax? Ax is minus of 5. I need to multiply with the unit vector of x-axis plus 5 root 3 j cap. This is a Cartesian representation of this vector. This is a Cartesian representation of this vector. Okay, now we will discuss just reverse of it, converting the Cartesian form to the polar form. How to convert if the vector is already given in a Cartesian form and it is asked to convert it into the polar form. Okay, consider the vector A given like ax I cap and ay j cap. This is a basic Cartesian form and it is asked to convert it into the polar form. First draw this in a xy plane. This is x-axis, this is y-axis. As per the given form, its component in the x-axis is ax. Its component in the y-axis is ay. Then how to find the resultant? Complete the rectangle. The diagonal will give you the vector A. Diagonal will give you the vector A. This is ax. This is also going to be ax. This is going to be ay. As the component of y-axis is ay. Now look at this. This is ay. This is ax. And it's a diagonal A. Next, magnitude of vector A is A. And what is going to be the value of A? A will be given by under root of ax square plus ay square. It means the magnitude of a given vector will be given by this. And this is suppose capital R. I am representing with capital R. And what is the angle of the given vector from the x-axis? Tan theta will be equal to ay upon ax from the given triangle. It means vector A can be written as, what is the magnitude? Magnitude is capital R. And what is the angle of from the x-axis? Tan inverse ai upon ax. This is a basic method how to convert the given vector in a Cartesian to polar form. Here I have converted the given vector into the polar form. What is the value of r? R is equal to under root of ax square plus ay square. This is the magnitude of the given vector and this is the angle of the given vector. And we know how to represent the polar form, magnitude and angle. The same thing I have written over here. This is a magnitude and this is a angle. Okay. Few points to remember when solving the numerical when you are converting from Cartesian system to the polar form. These are the basic points you need to remember. When the ax is given positive, then you are going to find the angle using this formula. Tan inverse ay upon ax. Theta is equal to tan inverse ay upon ax. But if you find that ax is negative, use this formula. Theta will be given by 180 plus tan inverse ay upon ax. This is an important point to remember while solving the numerical. Otherwise, you will get the wrong answer. We will see there are 4 different possible cases. We are going to see all the 4 different possible cases. Just take one example. The 4 examples we are going to discuss for different values of ax, different combination of ax and ay. Let's take case number 1. The first case is, suppose the vector is given as 3i plus 4j. What is the value of ax over here? Ax is 3, ay is 4. Then what is going to be the magnitude? We know the magnitude of the vector is going to be ax square plus ay square. It means r is going to be 3 square plus 4 square under root. It will give you 5. It means r, the magnitude, is equal to 5. Now, how to find the angle? We know the angle tan theta will be equal to ay upon ax is equal to 4 upon 3. So, from here we can write theta is equal to tan inverse 4 upon 3. So, the given vector can be written as, in polar form I am going to write this vector 5 angle of tan inverse 4 upon 3. This is a polar representation of given vector. This is a polar representation of given vector. Now, discuss the case number 2. Let's take another example. This is the first possible method. First possible case. Now, it is given like minus of 4i cap plus 3j cap. As I told, when ax is negative, you need to take care of these things. Ax is equal to minus of 4 and ay is 3. Then how to find the magnitude? Magnitude is going to be the same. R is equal to under root of ax square plus ay square. It means r is going to be, ax square is going to be 16, ay is going to be 9, this is going to be 5. It means r is going to be 5, same as the previous one. But how to find the angle? How to find the angle? Theta will be given by 180 plus tan inverse 3 upon 4. Okay, now to how to find the angle? We know theta is equal to 180 plus tan inverse ay upon ax. As I already told, when ax is negative, use this formula, use 180 degree. Now, theta is going to be 180 plus tan inverse ay is 3, ax is minus of 4. You will get 180 minus 36 point something, like 52 degree. From here you will get your answer approx 143 degrees. Theta is going to be approx 143 degrees. Then how to write in a polar form? What is the magnitude? 5 angle of 143 degree. This is a polar representation of the given vector. Now we will see the third possible case. Case 3. Suppose the vector is given as minus of 3i cap minus of 4j cap. Here ax is negative and ay both are negative. Ax is given as minus 3 and ay is given as minus 4. How to find the magnitude? Magnitude you will get the same, ax square plus ay square, you will get the 5, now same. How to find the angle in this case? How to find the angle in this case? Tan inverse ax upon ay, na? Okay, before doing that, just right click this, take minus as a common, 3i plus 4j. What do you mean by the minus sign in front of the vector? Reverse the direction. Reverse the direction means 180 degree, na? It means theta, can I write like this? 180 plus tan of 4 upon 3. It means theta is going to be 180 plus 53 is going to be 243. Here you can write the vector r is equal to magnitude is 5, the angle is 243 degree. This is a given polar form for the given vector. Okay, the third possible case we will see. Now we will see the fourth possible case. 4i minus of 3j cap. The vector is given like this. Ax is 4, ay is minus of 3. If you will calculate a magnitude, you will get r is equal to 5. And how to calculate a theta? No use of 180 degree because ax is not a negative here. Theta will be given by simple formula tan inverse ay upon ax minus of 3 upon 4. You will get a theta as minus of 37 degree approx. So we can write a vector as a 5 and angle is minus 37 degree. This is a polar form of the given vector. These are the 4 possible cases for converting the given vector into the polar form, given Cartesian vector into the polar form. Now we are going to introduce a z-axis. Till now we have discussed about x-axis and y-axis. Now we are going to introduce z-axis. Till now we have seen the vector as a component of ax and ay. X-axis component and y-axis component. But to represent any point in a space, we require 3 coordinates, x, y and z. Suppose this is a z-axis. As we know, a unit vector along the x-axis is represented by I cap. A unit vector along the y-axis is represented by j cap. Similarly, for the z-axis, we use a k cap. K cap is a unit vector along the z-axis. Unit vector of z-axis or unit vector along the z-axis. To represent any point in a 3D or space, we require 3 things: x-axis coordinate, y-axis coordinate and z-axis coordinate. Okay, to make the things easy, let's look at this example. So this is x-axis, this is y-axis and this is z-axis. Suppose this is 3, this is 3. Okay, not a cube, 3, and because I'm going to take the different values for different arms, 3, this is 4 and this is 4. This is going to be 4, this is going to be 4, this is going to be 3, this length is going to be 3, this length is 5, suppose this is 5, this length is 5 and this length is 5, and this is some point A. If I am asking you how to reach a point A from the origin, and you need to walk in the line only, what you will do? And it's the rule to always write a coordinate like first x, then y, then z. You need to write a coordinate of any point in this manner: x, y and z. Okay, to reach a point A, you need to first walk 3 in x-axis. You need to walk 3 in x-axis. Okay, then we have to walk y on a y-axis, 5 point on the y-axis. Then you need to walk 4 on the z-axis to reach the point. So this point will be known as coordinate of that point A. Coordinate of point A. This is a coordinate of point A. Yes, I am representing x-axis, y-axis and z-axis. Okay, let's look for the vector. Till now we have discussed a vector as a form of x-axis component, y-axis component. Now, suppose there is a vector in a space, it will also have a z-axis component. So we will write the vector as vector A, x-axis component multiplied by unit vector along the x-axis, y-axis component multiplied by the unit vector along the y-axis, and additionally we will get z-axis component of that vector multiplied by the unit vector of that direction, means unit vector of the z direction. This is going to be the complete representation of any vector in the space. Okay, this is a representation for the xy plane only, xy plane. But here this is a representation of vector in the space. Okay, just look what is written over here. To represent the location of a point in a space, we need third coordinate called z coordinate, which represent the height or depth of the over the xy plane, which we need to travel to reach that desired point. This is called z direction. The unit vector along the z direction is k cap. This is k cap. Okay, similar as I cap. For x-axis, what is unit vector? I cap. For y-axis, this is a j cap, and for z-axis, this is k cap. This is a basic representation of any vector in the space. You need to remember this. Now, suppose the given vector is given, the vector is given like this, and it is asked you to find the magnitude. Okay, for how to find the magnitude of vector A over here, in this case, we will simply find the magnitude like ax square plus ay square. Now, how to find the magnitude of this vector? Same method. Magnitude of this vector will be given by ax square plus ay square plus az square. This will be the magnitude of this vector. This is the magnitude of xy plane vector. This is the magnitude of the given vector in the space. Okay. Now we will discuss what do you mean by position vector. What do you mean by position vector? Just read what is given. The position vector of a point in the space is defined as a vector joining the origin to that point. Okay, let's see. Suppose this is x-axis, this is y-axis, and this is z-axis, and here I am having one point whose coordinates are given as, suppose 1, 3, 4. X-axis 1, y-axis 3, z-axis 4, and it is asked to find the position vector of that point. Position vector, this is point P. Position vector of the given point. Position vector of given point. How to find the position vector of a given point? First, draw the line from that point to the origin. Okay, and the direction of position vector will be pointing toward that point. Okay, always remember the direction of the position vector is going to toward that point. How to find the position vector? Simply write, suppose this is the way P and this I am representing with R. The position vector R will be given by, what is the x-axis? 1 now. 1 multiplied by I cap plus 3 multiplied by j cap plus 4 multiplied by k cap. This is a ax, this is ay, this is az. It means the given vector is I cap plus 3j plus 4k. This is a position vector of a given point. This is a position vector of a given point. And always remember the direction of the position vector. The direction away from origin, or you can say towards the point. This is a position vector of the given point. Okay, now we will see how to calculate a magnitude of a vector in 3 dimensions. Let's say a given vector is like vector A is equal to ax I cap, ay j cap plus az k cap. This is a given vector and I need to calculate a magnitude of this vector. Let's see how to calculate it. This is the x-axis, this is y, and this is z-axis. Okay, if you will see, suppose this is point A and this is the origin, and the point A is having a coordinate points as x, y, z, and this is a vector ax, ay, az. This is a vector ax, ay, az. This length is going to be ax, this length is going to be ay, and this length is going to be az. Similarly, this is also going to be az, and this also going to be the ay. Now this ay, these two are going to be ay, az and az. So now draw this line. Suppose this is a B point and this is a C point. Now look at a triangle OBC. It will look like this. This is point O, this is point B, and this is point C. OC is AX and CB is A of Z. What is the value of OB? OB square will be equal to AX square plus AZ square. Take this as equation number 1. Now look at a triangle OBA. OBA. This is O, this is B, this is A. This is a 90 degree. We have already calculated the OB. Now, what is the value of AB? This is going to be A of Y. Okay. This is a given vector whose magnitude we need to calculate. OA now. OA will be given by OB square plus AY square. I am just using a Pythagoras theorem. Now put the value of OB square from here to here. You will get OA square as AX square plus AY square plus AZ square. It means, what is the value of OA? OA means the magnitude of vector A. Magnitude of vector A. This will be equal to under root of AX square, AY square, AZ square, which we have already discussed in the previous topic. Just for derivation purpose, I have shown how to calculate the value of magnitude of vector in 3 dimensions. This we have previously seen now. This one. Okay. This is the way to calculate the magnitude of vector in a 3 dimension. Now we will discuss the direction cosine of a vector. What do you mean by the direction cosine of a given vector. Suppose there is a vector which is making angle alpha from x-axis, beta from y-axis, and gamma from the z-axis. There is a vector which is making angle alpha from x-axis, beta from y-axis, and z and gamma from the x-axis. Then simply the direction cosines will be known as like this: cos of alpha, comma, cos of beta, comma, cos of gamma. These are known as direction cosines of the given vector. Okay, now look at a diagram. Suppose there is a x-axis, y-axis, and z-axis, and here this is a point and this is a given vector. This given vector make angle alpha from the x-axis, make angle alpha from the x-axis, and from y-axis it's make, let's change the color, from y-axis it's make angle of beta, and from the z-axis it's make angle of gamma. This is a given vector. Given vector make alpha, beta, gamma respectively from the x, y, z. Then we will write this as a direction cosines of the given vector. And remember one identity: cos square alpha plus cos square beta plus cos square gamma is always equal to 1. This is a property of vector cosines. This is a property of cosines of the given vector. Always remember, when the alpha, beta, gamma are the angles of the vector from the x, y, z respectively, then cos of alpha, cos of beta, and cos of gamma is known as direction cosines, are called direction cosine of a given vector. Okay, for the direction cosine, write down one numerical. If alpha, beta, gamma are the angles of vector from x, y, and z axis respectively, find sin square alpha plus sin square beta plus sin square gamma. This is a question. Now how to solve it? We know for the cosines of the given vector, cos square alpha plus cos square beta plus cos square gamma is always equal to 1. This is identity of the vector cosines. Now we know sin square theta plus cos square theta is equal to 1 now. Is equal to 1. Same thing I am going to use over here. Can I write the cos square alpha as 1 minus sin square alpha? Similarly, I am going to write this as a 1 minus sin square beta. And for cos gamma, I am going to write 1 minus sin square gamma. This is equal to 1. Now here, 3 minus sin square alpha plus minus of sin square beta minus of sin square gamma is equal, just I have opened the bracket. Now solve it, you will get sin square alpha plus sin square beta plus sin square gamma is equal to 3 minus 1 minus 3, you will get minus of, sorry, you will get, because minus I will directly multiply, you will get, this is the value of the given expression. This is the final answer 2. Now we will discuss the displacement vector. This is a very important point for the numerical point of view. Just read what it is written over here. If a particle moves from one position to another position, then the change in its position vector is called the displacement vector. Let's see. Suppose there is one point. Suppose there is one point. Then what is the position vector of this? This one. Suppose this is a Ri, vector Ri. Now I have displaced this point from this location to the new point like this. I have displaced this point from the initial position to this position. Now this is going to be the position vector of that point. This is the final stage. This is a final stage. Then this vector is known as displacement vector. This is a displacement vector. Displacement vector of that point. How to find a displacement vector? Displacement vector will be given by the final vector minus the final position vector minus the initial position vector of the point for which we have make a movement. Okay, let's see again. Suppose there was a point at this point. This is going to be the position vector of that point. Now we have moved this point to this location, this new location. Then this RF is going to be the position vector of that point, because we know what do you mean by position vector. Suppose there is a point, when we draw the line from origin to that point, this is called the position vector of that point. Similarly, the position, initially the point was at A, then this OA will be the position vector of that point. After the movement, this point reaches to B, then OB will be the new position vector of that point. How to find a displacement vector? The final position vector minus the initial position vector. Okay, let's try to understand this thing with the help of an example. Find vector AB if point A 4 minus 4 0 and B is given as minus 2 and 1. This was the first point, point A, and this is a point B. It means point B is a final point now, and this is the initial point. This is an initial point, and it is asked AB. AB means AB is going to be the displacement vector. It was like in a coordinate system, there is a point A, and how to find a position vector of point A? This will be the position vector of point A. Now we have moved this point A to point B, then this is going to be a new position vector. This is going to be the position vector of point B, and this displacement will represent the displacement vector. AB is asked, displacement vector is asked. So what we need to find? First we will find the initial position vector, means the position vector of point A. Position vector of point A. The position vector of point A will be given by 4i cap minus of 4j cap minus of 0k cap. Now because z-axis component is 0, so we can write a 4 of I cap minus of 4j cap. This is the position vector of point A. Now similarly, find the position vector of point B. Minus of 2i cap minus of 2j cap minus plus of 1k cap. This is the position vector of B. How to find the displacement vector AB? How to find a displacement vector AB? Final minus initial means position vector of B minus position vector of A. You will easily find the vector. What is the position vector of B? Minus of 2i cap minus of 2j plus of k minus 4 of I minus 4 of j. You will get the final answer as minus of 6i cap plus 2 of j plus k. This is a displacement vector, or this is a vector AB, minus of 6i cap plus 2j plus k. This is a vector AB. Okay, is it clear? Okay, now move to the next point. Multiplication of a vector by a scalar. Suppose the vector is given and we are going to multiply that vector with some scalar quantity. Just read what it is written over here. Whenever a vector is multiplied by the scalar, the magnitude gets multiplied and direction remains same. If it is a positive scalar, and direction reverse if the scalar is negative. Just look what it says. This is a if. Suppose the vector is given like, vector F is given like 6 Newton east, and you need to multiply the 3. Then what will be the 3 vector F? Just multiply 3 with this. 6 3s are 18 north Newton east. This will be the value of 3F. But suppose you need to multiply the minus 3 from the F. Then what is going to be the value of minus of 3F? It is going to be a 18 Newton. This east, this direction is going to be reversed. Now direction is going to be west. When you are going to multiply with a negative scalar, the magnitude is going to be same as positive. Magnitude in the both case is going to be same. Only the direction is going to be reversed. Direction is going to be reversed. Same thing written over here. Direction reverse if the scalar is negative.